Now in this video we're going to explore the specific case of factoring a large polynomial given some zeros, but we're going to deal with ones where we have some complex zeros present, something with imaginary units. So let's look at this example. I got f of x equals x to the fourth plus 5x squared plus 4, and I know that negative I is a zero of this polynomial function. Now the first thing I would point out, and you should always remember this, is that complex zeros always come in pairs, because remember, whenever you get those complex solutions to a polynomial equation, it's always something plus or minus something times I. So it's always a pair, plus and minus. So I know that if negative I is a zero, positive I is also a zero. If this said 4 minus 2i was a zero, I would also know that 4 plus 2i is a zero. Okay, so what I want to do with this is I want to perform synthetic division to find out what the remainder would be if I divided everything by negative I. So again, put that in the box. 1x to the fourth, 0x to the third, 5x squared, 0x, and 4. So bring this one down. Negative I times 1. This will also be good practice of how to do synthetic division with imaginaries. Negative I times 1 is negative I. 0 plus negative I is negative I. Negative I times negative I is positive I squared. But what's I squared? I squared is negative 1. So that's 5 and negative 1, which is 4. 4 times negative I is negative 4i. Negative I times negative 4i is positive 4i squared. But again, I squared is negative 1. So that's 4 minus 4, which is 0. And again, I got the 0 remainder, so that's what I wanted. So that means that the resulting polynomial I get, and just to write it in its factored form, if minus I is one of the factors, that means that I can write this as, if minus I is a 0, that means x plus I is a factor, and the leftover is x cubed minus I x squared plus 4x minus 4i. Now we're going to try to factor that a little bit more. Well, again, if negative I is a 0, positive I is a 0. So let's do the leftovers divided by positive I. So that's 1x cubed, negative ix squared, 4x, negative 4i. Okay. Bring down the 1. I times 1 is I. Those cancel. I times 0 is 0. 4. I times 4 is 4i. Again, I get a 0 remainder. So that means that x minus I is a factor, which we knew it was. They always come in pairs. And now the leftovers are x squared plus 4. Okay. Now, some people might choose to leave that as x squared plus 4 because we know that that's not factorable using real numbers. However, since we are using complex numbers, that is factorable, because if I want to find the zeros of x squared plus 4, if I set that equal to 0, I could use the quadratic formula, but I don't need to here. I can just say x is equal to plus or minus the square root of negative 4, which is plus or minus 2i. There's my other two zeros. One of them is positive 2i, one of them is negative 2i. So that means that I could rewrite this way. X plus 2i, x minus 2i. So there is the fully factored form using complex zeros of this original function. Okay? So the complex ones are a little more complex, a little more difficult, but they follow the same pattern. So that's how we deal with those. Now, one quick comment, I'm not going to do one like this in the videos, but if you see one that says that it has a multiplicity, for example, it says that it has a 0 of 5 with a multiplicity of 2, that just means that factor is repeated twice. So if a function has a 0 of 5 with a multiplicity of 2, that means it would have the factor x minus 5 and another factor of x minus 5. So every time the factor is repeated, that's a multiplicity. So you have to take that into consideration. Okay? That's it.